I'll now be starting the questions on Chapter 5 in your workbook, starting on page 185. And for the very first problem, I need to find all critical numbers for the following functions. So for my very first problem, I have a cubic function, and if I want to find the critical number, I just need to take the derivative and set it equal to 0. Alright, so I take my derivative by writing out y prime, and x cubed, the derivative of that would be 3x squared minus, and the derivative of 12x is 12. And after that, I would set that equal to 0. And then on the right hand side, I can factor this out by factoring out the GCF. So from 3 and 12, the GCF would be 3. And then I can factor that out to be x squared minus 4. And then you'll notice that we have a difference of squares here. So this x squared minus 4, I can continue to factor that. That's x plus 2 and x minus 2. And the 3 can remain in front, and that's being set to 0. And all you have to do now is evaluate these binomials I'm highlighting here. So this will give you a critical number of x equals to negative 2, and this binomial will give me a critical number equal to x equals to 2. So here are my answers: x equals to positive 2 and x equals to negative 2 for my final answers. Okay, let's move on to the next question here. For this next question here, you'll notice that I do have some fractions here on the power. So in order to find the derivative, I would use the power rule. I would start by writing off 3, and then this 4/3 would come out in front, so 4/3. And then this would be x to the power of, well, if I have 4/3 and if I subtract 1, that's the same thing as subtracting 3 over 3. So 4/3 minus 3 over 3 is going to be 1/3. And then minus 12, and then I have this 1/3 here, which comes in the front when I take the derivative. Then x to the power of, okay, so if I have 1/3, I need to subtract 1 from that, so that's 1/3 minus 3 over 3, and that's going to be negative 2/3. So this power here will be negative 2/3. So you do have to work with your fractions a little bit for the start of this problem. And then I'm taking my derivative and saying that equal to 0, and then I need to simplify the right hand side. So 3 times 4/3, you'll notice that the 3's will cancel off, giving you a 4. So 4x to the power of 1/3 minus, and then this 12 and 3, 12 divided by 3 is 4, so that's going to be 4x to the power of negative 2/3. Okay, so now I have this expression right here, and I need to set this equal to 0. Now, when you're dealing with expressions when you have fractions as your power, ask yourself, which power is lower? Is it the 1/3 or the negative 2/3? Well, the negative 2/3 is smaller, so you always factor out the term with the smaller power. So my GCF would be 4x to the power of negative 2/3. So that is what I'll be factoring out of my expression now, and that's going to be equal to 0. And now you have to figure out what goes inside the bracket here. So in order to do that, what you're really doing is when you're factoring out a fraction from your original expression, let's just take this term for example there. That's 4x to the 1/3. If you're factoring out the GCF from here, what's happening mathematically is you're just dividing by the GCF, which is 4x to the power of negative 2/3. So what is that expression there? Well, the 4's cancel off. And then you'll notice that the bases here are the same. So the base here is x and x. If the bases are the same, and if you're dividing, you would want to subtract the powers. So that's an exponent rule there. And that's the same thing as x to the power 1/3 plus 2/3, which is equal to x to the power of 3 over 3, which is just, x to the power 1, which is just x. So now x would just go right here. Minus, and then this would just be a 1 here because essentially you're taking 4x to the power negative 2/3 out of that, so that goes into itself 1 time. Okay, so that's how you can factor that out by dividing and using your exponent rules there. And once you divide like that, then it's very easy to set this equal to 0, or it should be a little bit easier. But one more thing I'm going to do right here is I'm going to take this expression right here, and I'm going to rewrite that in terms of a radical. So this is 4 over the cube root of x squared. Okay, so let me just erase this right there. So this 2 right here is that 2 right there, and this 3 is that 3 right there. And then I have this bracket of x minus 1 here to finish off. Okay, so now I have this expression right here, and in order to set this equal to 0, this part right here is not too bad, x minus 1. So I take x minus 1, set that equal to 0, and then x would equal to 1. So this is one of my critical numbers right there when x equals to 1. And then when you take a look at this expression right here, take a look at the denominator here. You can probably agree that if the denominator here equals to 0, then this whole expression would be undefined. So that's also the definition of a critical number. It's when the derivative equals to 0 or when the derivative is undefined. So the x value that makes this fraction here undefined is x equals to 0. So this is also going to be another critical number there. So my answers are x equals to 0 and x equals to 1 for my answers there. I'm now moving on to the next question. Before I start the next question, the original problem didn't come out very nicely here. This is supposed to be a 2 here, so I'm just rewriting the problem down here. So the problem is y equals to the cube root of x times 2 plus x. And the goal is I want to find the critical numbers here again. So for this particular problem, I would take this radical right here and I would change that to a power. So that would be x to the power 1/3. And then that would be multiplied with 2 plus x. After that, I would take my my power here, x to the power 1/3, and I would distribute that into the brackets. And if I distribute that, I would get 2x to the power 1/3 plus. Now, when you're taking the x to the power 1/3, and if you're multiplying that with x, if I do a side calculation here, that's the same thing as multiplying this out. And on the x term, the part in blue, you'll notice that the power here is invisible 1. And 1 is the same thing as 3 over 3. So if the bases are the same here, you would just add the powers here. So 1/3 plus 3 over 3 is going to be x to the power of 4/3. So x to the power of 4/3 would be that, the next part right here. So this would be x to the power of 4/3. So y equals 2. And once you do that, then you can now just take the derivative and set it equal to 0. So let's go ahead and do that. The derivative is y prime. All right, so this 1/3 would come out in front. So it'd be a 2 times bracket 1/3 times x to the power of. All right, so if I have 1/3 and if I minus 1 from it, that's the same thing as taking away 3 over 3. So 1/3 minus 3 over 3 is going to be negative 2/3 plus. And then I have this 4/3. The 4/3 would come in front here, so it'd be 4/3 x to the power of, and then I would subtract 3 over 3 because that's the same thing as subtracting 1. So 4/3 minus 3 over 3 is going to be 1/3. Okay, so after that, we can now just simplify the 2 and the 3, the 2 and the 1/3. So that would be 2/3 x to the power of negative 2/3 plus 4/3 x to the power 1/3, and then I just set that equal to 0. Now this question right here is a bit tough because there's fractions in your powers again, but just like the previous example, what you want to do is you have to ask yourself, look at your powers here, what's smaller, the negative 2/3 or the 1/3? Well, this power here seems to be smaller, so the general rule or the trick that works is that's the term that you should be factoring out as your GCF, the one with the smaller power. So I can just factor out the entire term. So that'd be minus 2/3. And then if I factor that out, I'll be left with 1 here because I'm factoring itself out at the beginning. Plus, now this next part's a bit tricky because you're wondering what goes in this part right here. Well, basically all you're doing mathematically is you're taking this guy. Let me just kind of rewrite that over here. It's 4 over 3 x to the power 1/3. And if you're factoring something out, that's the same thing as dividing by the GCF. And the GCF is this guy right here. So we're just dividing 4/3 x to the power 1/3 with 2/3 x to the power negative x to the power negative 2/3. So this is the calculation that we need to figure out, and the result of that would go into that yellow spot right there. Okay, so let's just try to figure this out now. Okay, so let's take a look at the fractions here. 4/3 divided by 2/3. Well, 4/3 divided by 2/3. If you think about that using this in grade 8 math, that's the same thing as multiplying by its reciprocal. So I can multiply that by 3 over 2. The 3's would cancel off. 4 divided by 2 is going to be 2. So this guy divided by that guy gives me a final answer of 2. And then if I take a look at this part right here, the yellow part, if I am dividing and if the bases are the same, then you are subtracting the powers. So x to the power of 1/3 minus negative 2/3, which is x to the power of 1/3 plus 2/3. And that's going to be x to the power of 3/3 or x to the power of 1 or just x. So this x would just go right there, so the result would be 2x. So this would be 1 plus 2x to finish off the bracket there. So yeah, that was a bit of a tough one there. So a lot of it has to do with using your exponent rules from grade 9 math and remembering the concept of how to factor out a GCF. Okay, so after we're done that, then we can go ahead and finish off the problem here. Set that equal to 0. Sorry, the next part right here is I'm going to try to take this part right here and just write that as a proper fraction here. So the 2 would go up the front, the 3 would go on the bottom. Then this part right here, that's the same thing as the cube root of x squared. And then that would be multiplied with 1 plus 2x. Okay, so if you're not sure what's happening there, this 2 is that 2 right there, this 3 is that 3 right there, and I guess use a green color here, that 2 is that 2 right there, and this 3 is that 3 right there. Okay, so let's go ahead and set this equal to 0. If I do that, if I take this guy and set that equal to 0, this one's not too bad. This is 2x equals to negative 1, and x would equal to negative 1/2. So this is one of your critical numbers there. And once again over here, if x equals to 0, that would make the denominator equal to 0, and that would make this whole fraction here undefined. So the x value that makes that fraction undefined is x equals to 0, and that's also going to be a critical number because critical numbers are when the derivative, the x values when the derivative equals to 0, or the x values when the derivative is undefined. So the answers here would be x equals to 0 and x equals to negative 1/2. Okay, let's move on to the next question here, question number 6. Question number 6, I have a rational function here, and once again I want to find the critical numbers, and that's when the derivative equals to 0. So let's go ahead and take the derivative here. This is y prime equals to, and we're going to use the quotient rule here. So the quotient rule states that you take the derivative of the numerator. The derivative of the numerator is 0, and then you times it by the denominator, which is x squared minus 1. And then the quotient rule states that you need a minus sign, and then you would multiply by the top times the derivative of the bottom, and the derivative of the bottom is just 2x. All divided by the denominator squared, so x squared minus 1 all to the power of 2. Okay, so now we're setting this equal to 0, and just like in class, whenever you have a fraction equaling to 0, you don't really care about the denominator. The denominator doesn't really matter, and this term right here, that just goes to 0. So now you're left with just this term right here, which is just negative 8x. So you're just solving this equation right here. When is negative 8x equals to 0? And that happens when x equals to 0. So x equals to 0 is your final answer for that one. So that one was a quick one there. Okay, let's go on to the next one, question number 7 here. So this would be the last question for this part of the video, and I want to find the critical numbers for this particular problem. And over here, when you're given this, this is pretty much your domain right here. In interval notation, it's just saying that you can go from 0 to infinity. That's the same thing as x is greater than 0. So those two things pretty much mean the same thing. We're looking at if you have a graph right here, we're just looking at, this region, anything to the right hand side of x equals to 0. So that will come in handy when we're trying to finish off the final answer for this particular problem. Okay, let's go ahead and find the derivative here. And if I'm taking the derivative here, you should recognize that we have to use the product rule. So the derivative of x squared would be 2x times the second function, which is ln x, plus the first function, which is x squared, and then I would times it by the derivative of the second function, and the derivative of the second function is 1 over x. We're going to set that equal to 0, and then we just simplify this. So this would be 2x times ln x plus, and over here this squared and that x will just cancel off, giving you just the single x here. So 2x ln x plus x, and then we set that equal to 0. Okay, so in order to do that, let's go ahead and factor out the common term here, which is x. If I factor that out, I would get 2 ln x plus 1, and that's being set equal to 0. And to finish this off, this part right here means x equals to 0, and this part right here literally means 2 ln x plus 1 equals to 0. And in order to solve this guy, this would be 2 ln x equals to -1. And then I would divide both sides by 2. So now I have ln x equals to -1/2. And in order to get rid of the ln right here, the trick to that is you have to raise everything to the power of e. So that cancels that off, giving you just x equals to e to the power -1/2. So this right here is one of your critical numbers. And you might think that x equals to 0 is your other critical number, but at the beginning of the problem, the domain was from 0 to infinity, and you'll notice that, you know, this part right here means we don't include 0, right? So I also said at the beginning of this problem that's the same thing as x is greater than 0, so we don't include 0, so this one right here we just reject. So this right here is our final answer for that particular problem.